Good morning, good afternoon, good evening, everyone out there in the internet world. How are you today? I am Chris Short, Principal Technical Marketing Manager at Red Hat. Forgot who I was for a second. These things happen. It's COVID-19 season. I am joined today by a wonderful group of people. My fellow Red Hatters, Serena Doyle, and Jay and Ryan, and I'm just so excited today. Like today's topic, 4.6 Knative. It's going to be great. It's going to be awesome. I'm going to let Serena introduce herself. Serena, take it away.
Awesome. Thanks. Yeah, my name's Serena. Some of you know me as Serena Doyle. Some of you know me as Serena Nichols. Unfortunately, the Zoom doesn't allow me to change update my last name here, but I am Serena Nichols now. You might know me as both. No worries at all. So welcome back to our OpenShift Developer Experience Office Hours. Really excited to have you guys here. I'm going to hand off to Jay for some introductions, and then I'll be back.
Thanks a lot, Serena and Chris. So my name is Javardhan. You can call me Jay. And I work with Red Hat as a UI engineer. So primarily I'm working these days on OpenShift Dev Console, so trying to enrich the developer experience. So glad to be here. Thanks.
Thanks, Jay. Yeah, so today what we are going to be doing is we're going to focus on the developer experience in the OpenShift console. And we'll show a sneak preview of what we're working on for 4.6 and further. So we're going to be sharing from our development environment, as well as a few videos from PRs. So we're likely to run into some snafus along the way. So if so, don't be surprised. I'm going to start sharing first with some overall features that we're adding, and then I'm going to share off to Jay later on, and he's going to go into some extensive Knative features that we've been working on. So let me get started. I'm going to pull up share my screen. Just make sure you guys can see that.
Yes.
All right, excellent. So one of the things that we're going to do, one of the things that we're adding inside of 4.6 and further is an improved getting started experience. And part of that is kind of like our guided tours. We're going to rename these to quick starts, but right now in the UI, it's still called guided tours. Yes.
All we can see right now is your desktop and notes.
Oh, interesting. Thank you for saying that.
No problem.
Let's stop sharing and start again.
Start sharing again. The joys of sharing screens.
Let's see if this will work.
We've only been trying to do this for like 20 years or something. There you go. There looks
we
like
go.
An OpenShift console I know and love.
Yeah, there we go. Okay, awesome. So here we go. So as I was saying, what we're going to be doing in 4.6 is we're going to focus on the getting started experience. So I think last time we talked about this as well, like the default perspective will be changed for people who are non-privileged users to be the developer perspective. Another thing that we're going to be doing is adding this kind of guided tours section. We're going to change this to quick starts, but what we'll be able to do is kind of look at all the guided tours that are available. And some of these will include things for admins to be able to install serverless operator, install pipelines operator. But then for the developer, we're also going to be able to provide some quick starts to start creating a serverless app, or how do you quickly start using pipelines. So this is quick, just a preview. We don't have the content in here, but what will happen when you click on one of these items is, there we go, snafu right away. What you'll see on the right-hand side is some instructions that come out, and you'll be able to follow through the instructions to either install operators if you're an admin, or get started with creating applications. In addition to that, you can also, if you're on a different page and you want to be able to reaccess that stuff, you'll be able to go to the help menu and go back to guided tours and see that content available for you again. On the add page, what you're also going to see is I have a little animated GIF here, which we're going to add a samples card to the add page. And when you click on samples, it's going to show you all of the available samples that you can create. And then it's a very, very short form for people to be able to get started very quickly, to just kick the tires, get started with a sample. And we're hoping that this will enable that onboarding experience much easier than what we have today. Another area that we have worked on a little bit is the monitoring area. So I think a lot of you guys probably already know that when you go into topology today, we have the ability to kind of click on an item. In the right-hand panel, you can see a monitoring tab, and you have the ability to view a monitoring dashboard. So when we go there in 4.5, we show the context of what you're looking at, but in 4.6, what we're enabling you to do is change the context of that dashboard. So again, if I go back over to topology, what you'll see is I have 3 deployments. I can jump into that dashboard if I want to from here, and I'm in context of the Hello OpenShift deployment, but then I can really quickly and easily switch between deployments to see this dashboard based on context that I'm setting up here, which are, I think, pretty nice changes. In addition to that, we've got some more work that we've done in Helm. And let me show you some of that. So I'm going to go into the Helm catalog quickly here. And what we've done here is now, if you have multiple versions of a chart, we're only showing it as a single tile inside of the Helm catalog. Previously, we were showing multiple. So now what you can see is if I click on this Helm chart and say install, I'll see that I have multiple versions available here, and I can decide which version I want to install. So this is pretty nice because you can do well, for 2 reasons. It makes the Helm catalog look a little cleaner because there aren't multiple instances of the same chart. And then when I do the install here, another thing that's really nice that you can see right off the bat is that we now have a form view. So not all Helm charts will have form views. You need to have an associated schema in order for us to generate that form-driven experience. So those that don't have the schema, what we'll do is just we'll go back to the YAML driven. So give me 1 second. I will select this one, which does not have a schema. And what you'll see is we're forced to go into the YAML view. And it does say that the form is disabled because there's no schema available. I can get rid of that. So I have a little bit more room inside of my YAML editor, but that's the experience. So it's going to be nice what we're trying to do across the boards. And this came up, I think this came up yesterday, Chris, when Steve and I did the Ask the PM session. What we're trying to do is provide more access to form-driven experiences across the board as we continue with our releases.
Yeah, it's great to have the YAML editor and any future kind of terminal we're planning, and all those fun things baked in. But it's also nice to have that form-driven flow, right?
Yeah.
Some people prefer that, and having that as an option can also help a lot of people get started with technology they're not exactly 100% familiar with, but all of a sudden they have to start using.
Right. Yeah, definitely. While I'm still in here, what I'm going to do is I'm going to just quickly go over one of the features for 4.5 because I'm not sure that everybody who's here today was in the meeting when we went over this previously. This is just one really nice one I think that we have done in 4.5 where if you frequently access resources that are not currently on the navigation, there's a very quick and easy way to add it. So say pods is something that I quickly reference. Or frequently reference. When I do the search, I can click on add to navigation. And when I do that, you can take a look down here on the left-hand side. That third section of resources are things that as a developer, as a user in the developer perspective, you can kind of customize that last section really not easily. So now, when I exit the console and come back, I'll still be able to see pods here. And if for some reason secrets is something that I don't frequently use, I can just hover over the item, I see the circle, and I can remove that from navigation. So 4.5 is out, and that is something that people can start using as soon as they upgrade to 4.5.
Nice. So customized views. That's kind of nice.
Yeah.
That's really cool. I like the idea of being able to pin specific resource, high priority resources on the side over there. Is there any planned support for adding, like, let's say I had an application CRD that I wanted to pin? Is that in the plans at all?
So trying to think, would we be able to search for those? And I think anything that comes in as a custom resource comes in the search drop down, right? So as long as it does, you could hypothetically pin that. And Jay, I wonder if when you're doing the, put you on the spot, when you're doing
with OpenShift 4, pretty much most of these are architected as CRDs, right?
Right.
So
Yeah, and Jay, I'm wondering when you do the connector demo, you can show maybe some of that we could actually pin the connector resources onto the nav as well.
Yeah.
Nice.
Yeah.
So we got a question or some feedback in chat here that you might want to take note of, maybe copy paste somewhere for yourself there, Serena, or I can do it for you. On metrics dashboard, there are several charts where the y-axis labels are useless stuff like 0.01, 0.05, etc., or better yet, scientific notation 4.1, E7, etc.
Okay.
Any plans able
Great
to make
feedback.
these axis labels more human readable? I will send that.
We can definitely look into that and get our user experience team looking into doing that. I can definitely put something like that on the backlog.
Thank you, Conspirator. Sorry if I said your name wrong. What charts, if you have any examples, that would be super helpful. But if you don't, that's cool too. No worries. We'll look into it.
Yeah. Okay.
Thank you. And then
awesome.
Steve says he pins Knative service resources. Works great.
That's great. Awesome.
That's great. Great feedback. Awesome.
Good news.
Thank you.
All right. Well, with that, I think what I'll do is I'll hand over to Jay for the Knative piece, and hopefully he'll do a better job than I did with sharing his desktop.
It is live streaming.
Yeah.
Yeah. Thanks, Serena. Thanks a lot. So let me share my screen. So let me know if you guys can see my screen.
Yep. Got your whole desktop in front of us.
Oh, sorry.
You're fine.
Yeah.
There we go.
Yeah. So in today's session, like we have some agenda we wanted to talk about. So primarily it's about like for 4.6, what are the new features going to come in? And before we start, like this is primarily from serverless point of view, or Knative we call it. So we'll be talking about introduction of serverless and its benefits. It's good to set some context. And then we'll be talking about channels and subscriptions, which is going to come into dev console for 4.6, and then brokers and triggers. And what are these things? Then maybe we can, we'll be showcasing this in the demos. So,
awesome.
Sorry. So what is serverless? Basically, I think pretty much many of us would be knowing that serverless computing refers to the concept of building and running applications that do not require server management. So it has a lot of benefits, like in terms of resources, in terms of usability. It is doing a lot of work behind the scene for us. So this is the definition from CNCF. And OpenShift serverless is the operator which is needed into OpenShift to power all these features, and which is based on the Knative, which is the upstream project. So it is like Kubernetes-based platform to deploy and manage modern serverless workloads. And primarily, there are two components for serverless or Knative. One is serving and one is eventing. So what are these? So serving is basically a request-driven model that serves the container with ability like auto-scaling or scale to 0. And eventing is based on the cloud events. It provides a common infrastructure for consuming and producing events that will simulate applications. So that was about the higher level, what are these components. So let me quickly go to serving. And so we spoke about like route, scale to 0, and track application revision with ease. So let me talk a bit more about it. So it is like demand-based auto-scaling. You can set your min pods or max pod, unlike regular deployment where it to set upfront. So depending on that, it will scale it and based on the need. And it also helps you to maintain the separation of code and configurations. I mean, each revision is a state which you can be maintained for different changes. So maybe I'll showcase one example in demo, just to talk about it a bit more. And then we have a rich capability for traffic splitting. You can follow any deployment strategies, be it blue, green, or canary. for doing the deployments with this traffic split capabilities. So that was about the serverless. And in terms of resources, so in this diagram, you can visualize like what all things are there. So service is the root level entry. It's not K8 service, it's Knative service. We even call it as KSVC. And it manages route and configurations. So in turn, every change will trigger a revision. So change could be in configuration or could be into the image or anything. So each revision will be a state, and we can even, as I told earlier, you can follow any deployment strategy and you can split the traffic based on the revision. So assume that you are working on some cool feature which we want to roll out, but not to the entire user base, to a subset of user base. So you can decide based on the percentage. We can go as low as 1% and as high as anything. So this is what revisions, routes, configuration, and service is. And yeah, so earlier, I mean, if you see this YAML, so this is how K8 deployment is created. You need to provide a lot of informations, and with Knative serving coming in, just you have to mention the image selector and the templates. So no need to worry about the service, ingress, routes, etc. It will handle everything for you. Now we'll go to eventing and talk a bit more about it. So eventing, as I told earlier, is a universal subscription, delivery, and management of cloud events. So it is based on CNCF again. So it gives the flexibility of routing the events from one source to different sinks. So these sinks could be any service or URI, or it could be anything which can subscribe to it, basically. So with Knative serverless operator or OpenShift serverless operator, we get to create two CRs, like one is for Knative serving and one is for Knative eventing. So those are the two components which I spoke about earlier. The moment you create a resource for Knative eventing, you will get this built-in sources, which will be part of the operator itself, like ping source, API server source, sync binding, and container source. But along with that, in Dev Console, we also support the contributed sources. So that can be installed by any other operator or any source. As long as they are following the eventing mechanism, we should be able to discover it and show it to you into the Dev Console. So be it Kafka source, Camel source, GitHub source. And with 4.6, we are doing one more thing, as like we are identifying these Camel components as separate entity so that with ease you can create these sources. So be it Telegram, be it AWS instances, be it Jira, Slack, etc. So those things will be feasible with 4.6 via Dev Console. And now coming or talking more about the mechanism, how we can leverage it, how one event can be synced to a particular service or channel, or what are these things. So there are primarily three ways to do that. So one is which we call direct connection, where one source will sync to a service. So it's the simplest way to get cloud event to a service. But as you can see, there are some drawbacks of it, like there is no queuing support for service when it's available, when it's not available, and then only one service can consume events. We can't have same source going to multiple services, and there is no mechanism for filtering service get all the events. So let's talk about the, let's see demo now, something in action. So I'll move to here. So just to, before we start, just to brief on this. So if you see, I have already installed the operators, which I spoke about. That is OpenShift serverless operator. And I've also installed Knative Apache Camel just to demonstrate the contributed sources. So I'll go to developer perspective now. And you can see over here, I already have one service created, so which is greeter. So the moment you click on this route, you can see the pods were not there. It was scaled to 0. And it is caching, I believe. So let me just reload it. Yeah. You can see the pods are coming up. So it is scaled to 1. So the moment the request comes, it holds the request and serves that. That's what I was trying to say about auto scaling or scaling to 0. Now quickly, let me go ahead and show you what it does. So if you see here, it just shows a greeter like namaste, which is nothing but hello. And I would quickly like to go and change it. So with great ease, you can just do edit greeter. This is picked through an environment variable. So you can just go and change it to something else. I'll call it hello now. So now we have 2 revisions. I think we should be having that. Yeah, because I made a change to a service. So if you see in sidebar, there are 2 revisions. The second one would be coming up soon. Yeah, it's up. So now if you try to click on the route, you'll be seeing hello. So depending on the environment change, it picked up quickly what was that, and it created new revision for that. So that's what I was trying to say when we were talking about the revisions and configurations. Now assume that we want to roll it out or do some traffic splitting on it. With great ease, we can do through dev console. I mean, you can just add a more entry. We'll call it say 50. And we'll also use a tag now, tag 1. And we'll again call it 50. And we'll call it tag 2. And this time we'll select the new revision which came up. And I'll do a save. The moment you do traffic split, it will show the routes going into different revisions over here. And now if you click on these routes, you can see, depending on the URL or the revision, it will pick. It's namaste greeter for tag 2. And if you click on tag 1, it will be hello. So this division or percentage you can do to check your deployment. So that was about serving. Now quickly, let me go to eventing. So I'm going to my IDE where I have some examples or some samples. So before we start showing, so basically I'm trying to demonstrate this time API server source. So API server source listens to any Kubernetes events and try to show that or fetch that sources or those events, and that can be synced to any services. So that needs access for service account. So I already created in this namespace. Now quickly, if you see, this is a sample service which I'm going to use, which is syncing to a particular image. So let me go to dev console again and try to create one. So I'll use event display. I'll keep it, yes. I'll take the application name off. I'll select Knative service here. So there are 3 options. You can choose Knative service. And for the name, just to be consistent, because I'll be doing a lot of things over here, I'll just use service 1. And we'll create it.
It's funny. I just muted my mic because my dog was barking. Now someone else's dog is barking. It's just awesome. I love the work from home environment we're in now.
Yeah. So the pods are like coming up for this service, Knative service, which I just deployed. So meanwhile, let me show you what is API server source. So if you go to this YAML, this is of kind API server source, which will be creating next through web console. And it will be listening to events for which already I gave access through service account. So let me quickly go to the dev console again, and I'll go to add. So if you have the serverless operator installed and CR created for Knative eventing, you can see this card or tile here for event sources. The moment you click on it, it shows all the event sources over here, be it contributed, be it built in. And API server source is there. So quickly, I'll call it V1, and I'll call it event. I'll change the mode to resource, and I'll select the service account which I created. And the source I'll call service 1. So you can select anything from here. You can even provide URI option. And just to check, the name I'll be giving test events this time. So I'm going to create it. So as you saw, I'm syncing it to the service which I just created. So this is the event source which is syncing to my service, and this connector shows the relationship between that. So if you see the pods are coming up slowly, it is running and automatically starts pushing event to this service. So if you go to the logs, if there are any events coming, it should be shown up over here. As you can see, it's streaming it. So based on this event subscription, anything can be achieved through the service, which is listening to it or subscribing to it. So let me go to topology again. So that was about the first example, which we spoke about, that is sync to service. Now let me talk about other things. So if you see over here, so that was about the basic example, but for that, there were some limitations which I spoke about, that different sources can't go to different subscriptions. So for that, we have channels. So channels are like multiple services can consume the events or same events. Subscription can point to reply channels. So basically, in simple words, if I'll explain, so these are the sources which is syncing to a channel, and these channels can be subscribed via different services through subscriptions. So let me quickly go to the demo for it, and we'll try to create this now. So let me take to the IDE. So for creating a source, as I showed in the slide, I'll be creating one event source. It will again be API server source, but this time it will be syncing to a channel, unlike last time. And then we'll be creating knative services with different names, say channel display 1 and channel display 0. And then we'll be having subscriptions. Subscriptions is nothing but provide a way to enable services to subscribe to a particular channel. So as you can see over here, we have like channel and we have subscriber, which is going to a service. So to, in order to make it quick, so I have created a simple script which will just try to install all of those things. Sorry, yeah. Where is, sorry. I'm in wrong directory. Just let me change it. Yeah. So I ran that. So basically, I'm trying to install these YAMLs here in order like service, channels, events, and subscriptions. So you can see in the log, it is trying to create these. So these things can be created through dev console as well. But just to make it quick, I'm trying to install these things through CLI, because I have the script over here. Now let me take you to the dev console. So you can see over here. So the moment we did this deployment, so in topology, we can see all of these resources being in connection. So we have API server source, which is syncing to a channel, and that channel is going or subscribed by different services called channel display 0 and channel display 1 via subscription. And again, if you check the logs of this, you can see they are receiving the events. So it's loading. Yeah, here we go. So that was about the channel. I mean, one channel can go to n number of services or can be subscribed by a number of services via subscriptions, and different sources can as well go to these services. So we are also working on improving this topology layout where it will be, I mean, will follow some alignments, but yeah. So you can see some of these resources. When you click on service, when you click on channel, you can see associated services, event sources, and subscriptions in the sidebar. And you can perform all the necessary actions just like you do with any other channels or sources. So that was about the channel. And if I'll go back to my slide, even channel had some drawbacks, like there was no way to do the filtration. I mean, all the services subscribing to a particular channel will receive everything. So there is no way to mention, okay, for this particular service, I want only these events. And for service B, I need only these events. That filter we can't achieve through channel. So for that, we have something called broker, which will maintain it and which will provide the capability to filter those events. So via broker, it is achieved through triggers. So triggers enable us to achieve all of these things. So let me go to my IDE and try to demonstrate this piece about the source and broker. So for creating a broker, we need to inject, admin needs to inject this particular label to the namespace. So my namespace is sample app. And if I try to inject this, and this will create a default broker. This needs to be there. So the moment I injected, if I go to topology, you can see the broker is already there. So broker is created or it has been injected. The pods and deployments are like up or it's coming up. So now we have the broker. So now what all broker needs? If you go back to slides, again, we need some sources which will be passing the data or syncing to a broker. And this broker in turn will be subscribed by different services. And filter will be playing the role for filtering events based on some custom type, source, or extensions. So these things are powered by filters. So let me take you to my IDE again. And as you can see, these are pretty much similar service which we created twice. So this is for, we call it broker display just to make it or differentiate it. And then we have KSVC2, two services which will be subscribing. And then we have again API server source, but this time we are syncing to a broker, unlike channel or service. And then we have ping source. So ping source is nothing but we are trying to schedule a job. It's more like every minute it will be passing this particular message to this broker. It is syncing to a broker. And now if you go to trigger, so as I told, trigger acts as a connector between the broker and the subscriber. So it takes the broker name and it takes the resources, whatever we are subscribing to or whatever wants to subscribe to the broker. So this will be the service in our case. And as you can see here, this is how we pass the filter. So what I'm trying to do for the service broker display, I'm trying to filter based on the type ping. So for this particular service, even though the broker will be synced to two sources or multiple sources, but this service, I would like to receive only the events associated with the ping source. And for trigger two, I don't want any filter. I just want everything to flow in. So let me quickly go ahead and try to create these resources. So again, I'll use the sample script which I have. So it will try to create the service, broker display one, the second service. And this is the API server source, ping source. And now we are trying to create triggers. So we have all our resources created. And again, this everything you can achieve through def console, as I showed earlier. So if you go to topology now, we have a lot of resources over here. So let me just try to make it visually aligned so that we can make out, okay, sorry. So there's something wrong happened with the trigger creation. I can't see one connector. So let me go and debug that, what's going on there. Yes. So this is test event triggers. Yes. Zero, it is using broker. It is going to broker display. We can't see this connection. So let me quickly go to search and just try it out here. In search, as Serena showed, we can see all the triggers. Yes, so let me arrange it again. Let me take this aside, and this is the for channel, which we formed. And now we'll take this as well aside for source to service, and this is the thing which we wanted to show now. So for broker, we have two sources syncing in. So one is ping source, one is API server source, and they are going to two different services. So as you can see, this a line over here, more like a perpendicular line, it denotes that it has some filters. So you can click on these resources. So we are working on it for 4.6. So you can even see these filters right here in the side panel. And if you go ahead and try to click on any of those logs, you can see the logs getting.
You know, it would be kind of neat too, Jay. I don't know if at some point you wouldn't mind going into display options and just changing it so that we see the pod count. Because I think that's one of the cool things too, right? When you see things automatically scaling up, you can see that number increasing in topology rather than looking at the icon.
Okay, for sources you're trying to say? So did you mean this, Serena? In the sidebar, you can see the ports.
No, I was actually, so you know, in the display options up on top in the underneath the project selector, yeah, and click on pod count. So I was just saying, like when your Knative services are scaling up or down automatically, you can actually see that there. In addition to, you can also see it on the ring, where the ring is blue when they're scaled up, but it's clear, I guess, or white when they're auto scaled down. But it's also a neat way to see that change.
Yeah. So yeah, that's definitely a good one. It gives a lot of insight to the user. And now if you see the pods are like up even for service, it means our filter is trying to pass the data depending on ping source. So now if you try to check the logs for this one, it should have only the ping source data, not the events coming through it, because we have the filter there. So let it load. If you can see, it just has the ping source, like hello world, what I was passing through that. So this is the beauty of filter. You can, depending on the type or source or extension, you can just prevent it and pass anything, or depending on the need. So again, like channels and number of services can subscribe to this broker, and we can achieve a lot of great features with different sources over here. So that was about the channels and the brokers, along with what subscription and trigger does. And next in serverless, I see like there will be a few more things which will be coming up. So that is like sequence, parallel, and ability to extend syncing to different things. Like currently, with sequence, you can have a chain of multiple services. With parallel, you can have some branching and conditional processing depending on the filters. So those kind of things will be coming up in future, like 4.7 or something like that. So I think, yeah. And one more thing I wanted to show before we just, that is about in the ad. If you go to ad flow and event source, so you can see a lot of different options here now. So these options are again work in progress. It will be increasing. So these are the camel components or connectors, we'll call it, which we are providing to the user. They can just click on it, and for this, it will be pre-filled YAML value, wherein user needs to provide some of the informations and just create or sync. As you see, it is syncing to a channel again. So user needs to go and create IMC for syncing this particular source to that particular channel. So That was about camel connectors or components. And if I go back to my slide now, so
Jay, can we just based on the connectors one too, can we just, I think the plan is for 4.6, what are we doing? I think there's maybe 7 high priority connectors that are going to be exposed in that form. Yeah, I'm sorry, in this user flow. And then we think that in the future, we're going to continue to add additional connectors, right? And even in post 4.6, we've talked about providing a bit different of an experience. So right now, the selection of the event source is part of this form. And I think some of the things that we're talking about is, should it be a more catalog-driven experience, where if you can have hundreds of event source types to select from, right? Should it be more of a catalog-driven experience? And just going to open that up to the chat for if people are doing anything with connectors today or event sources today, does anything like that resonate with what you're looking to do in the future? I think the other thing is, can you explain the difference between which ones are form-driven versus which ones are YAML-driven for 4.6?
Yeah, so yeah, for 4.6, all the built-in ones are like form-driven. When I say built-in, I mean, in my slide, I try to demonstrate whatever sources comes as part of serverless operators. So like API server, ping source, container, cron job is deprecated now, but yeah, we are showing it as it is there. And sync binding. So all of these things will be like form-driven. Even for Kafka, we support form. So you can identify bootstrap servers and other things. But all camel and the contributed sources like GitHub or anything if user is trying out, so that will be automatically shown in this view, but that will be defined through the YAML. So user needs to provide the values in the YAML to create or perform those actions. And yes, and one more thing to highlight here, I think I mentioned that earlier. So with 4.6, we are also providing this option of URI. User can sync to a URI directly instead of using a resource. So even in resource, you can extend, I mean, you can select broker or channel or native service, any of these things. And through UI, you can just provide a valid URL. It could be off cluster, in cluster, or whatever, I mean, which you need to sync to. So yeah, I'm not seeing chats. If there are any questions on that.
No, that's great. So, there was, I wonder, one other thing you could do while Chris is kind of looking through the chat is when you go into topology, could you, yeah, exactly. I was going to say, could you do a, add a nav item for one of these source types or whatever?
Yeah. Let me search API server source. I think I created a lot of those. So if you sync, see there are like 3 of those. So I'll say add to nav item. Now you can see like as in this namespace, there are a lot of resources. So quickly I can just come from anywhere and see, okay, what are my API server sources? So in order to extend it, so let me just add some more thing. So let me just add subscription. So messaging.knative, yeah. So if you see there are like different subscriptions and this triggers are also backed by subscriptions. So that is also shown here. Again, I can add that to a nav item over here.
Yeah, Ryan, I think this comes back to what you were saying before, is if you have custom resources, will this work too? And so definitely does.
Yeah, awesome.
And I don't know if I mentioned this earlier, but one of the reasons that we added this feature is because one of the things that we had heard when people first got their hands on the developer perspective was that they were switching over the admin console or admin perspective just to access things like pods, config maps, secrets, etc. So this was a way for us to hopefully alleviate some of that context switching. So
awesome. Well, we had a couple questions, and no, sorry, go ahead. But excellent demo example, I just wanted to say. And also, I think folks would like a link to your slides and to the repo sources.
Yes.
Yes.
I'll be sharing that in the chat. Yeah. And just one more thing to add, like as for creation, like as I told, you can create everything through dev console. but I didn't show it for the channel. So there is a work in progress actually. You can see even a card for adding channels, which will be showing you all the channel implementations, be it IMC, be it Kafka, be it GCP, whatever is in the cluster. So through that, you can create the channel implementation based on your OS. So I couldn't show now because that's not there as of today, but it will be there in 4.6. So I'll stop sharing now. And
awesome. So I'm looking back through chat. I think we've got the questions covered, but I've got some new things to look into, like the Telegram connector for Slack. That sounds fun. I'll tinker with that.
Oh man, we got a challenge thrown down to do a Twitch chat integration.
Yeah.
I think we only have a 1 hour limit on this session, but that sounds like an excellent. I'm going to fill it into our notes doc as an upcoming topic.
Yeah, like that.
At least
that sounds like something very interesting to maybe take a stab at. We could probably fit that in somewhere along the way. I'm sure that'd be fun.
Yeah.
All right. Anything else going on? I mean,
so I think a couple other things that we could briefly mention is that we do have a number of 4 or 5 blogs that were recently added.
Yes. If you go to blog.
So I can try to quickly find those. Yeah. And we can share them in here around all the great stuff that we've just added for 4 or 5. Mm-hmm. And I've also added a link to a survey. Again, if you're interested, we'd love to hear what you think about the format. If there's anything that we can do to change, new topics you'd like to hear about around the developer experience. It's always helpful to make sure that we're getting you guys what you'd like to hear. So
yeah. I can start. So are you doing the links, or you want me to do the links?
I am, if that's okay. Yeah.
No, go ahead. Please do.
I'll add 3 or 4 here real quick.
Beautiful. Thank you very much. Yeah, Steve points out a good disclaimer. We talked about features from 4.6. These are all work in progress and may or may not actually make the 4.6 release. Your mileage may vary. This is all future stuff. Anything is possible after the fact, right? So we might decide tomorrow, nope, bad idea, and then change directions based off feedback we got today. Who knows? So yeah, nothing you see here is concrete etched in stone, essentially.
Yeah, I think we started with that comment, but probably should have said that with every feature we showed.
Every feature, yeah.
Good point. Yes, yeah. These things are all currently in development, and based on a lot of reasons, they might not make it in 4.6.
Yeah, they might not make it in 4.6. They might roll to 4.7 for some reason. Who knows? So yeah, I mean, it's development, folks. You all know how hard it is. So Jay gave me the slides, and I don't know, Jay, you might get a lot of requests for people to open those slides. We need to figure out how to share slides better somewhere.
Oh yeah, because this is outside of Red Hat as well.
Yep.
Yeah.
So yeah, there's Jay's examples I just dropped in chat. As far as the slides, you on that, Ryan, or?
I can make an PDF export of the slides and put a link in the meeting notes. It may take a minute or two, but I can promise that if you follow the meeting notes, I'll update in there. Does that sound like a plan? Unless someone else knows it.
That sounds great to me.
Cool.
If you're on the live stream, hit up the notes, Ryan. If you could drop a link to the notes in the chat. Actually, I can drop a link to the notes. Let me just scroll up and grab it. Link. It really helps if I spread that out. All right, cool. Well, without further ado.
I guess the only other announcement I have, sounds like Serena might have one, but next week, same time, same place, me and the OpenShift developer evangelist or advocate team are planning on doing a demo of the, let's see, what do we got here? App topology and linking using the service binding operator. So if you're interested in getting your application workloads linked up with database services, and modeling that in a way that is consistent with Helm charts and other kind of Kubernetes best practices. We'll be talking about using the service binding operator to help facilitate that work.
Awesome.
Yeah.
That's going to be a great stream.
That's great.
Fantastic.
And then I think the following week or soon thereafter, we'll probably follow up with more stuff in 4.6, some of the changes that we're going to be doing in the topology view. I know that there is a bunch of questions and comments around the fact that this thing gets busy pretty quickly, and we're making some changes in 4.6 to try to, or we're making some future changes to try to alleviate that. And I think we'll also be able to share some of more of the implementation around the improved getting started and discoverability pieces as well. So we'd love to see you back every week.
Wonderful. Wonderful. Yeah. Thank you. Appreciate it every week. All of you tag teaming this and making this work. This is an awesome show every week, and people really appreciate it. So, and it shows in the stats. So thank you very much for putting it together. Without further ado, Brian Tanis says, nice fireplace. Thank you. Without further ado, we have coming up in just a few minutes at the top of the hour, OpenShift Commons briefing on, oh gosh, my mouse just moved. Simplifying software delivery with IBM Cloud Pak for apps with David Harris and Chris Bailey from IBM. So if you're interested in Cloud Pak, stick around, and we'll have some info on that in the next stream. Thank you all for joining me today. Thank you, Jay. Thank you, Serena. Sorry for using the wrong last name. Thank you, Brian. Thank you, everybody in chat, for helping each other out. Super cool talking to everybody today. Appreciate it. Have a great day, everybody.
Thanks.
See you next time.
Bye-bye.
Hello, everybody. Welcome again to another OpenShift Commons briefing. Today we have special guests from IBM, from the Cloud Pak for Applications team. We have David Harris, who's an offering manager for Accelerators, and Chris Bailey, who's chief architect for Cloud Native Solutions. And they're going to be talking about IBM Cloud Pak for Applications and the new Accelerators for Teams. So, and stick around for the Q&A afterwards, and please post any questions in the chat. Thank you. Please, David.
All right. Hi, everyone. I hope everyone is doing as well as can be expected in these times. My name is David Harris. I'm an offering manager for the Cloud Pak for Applications, and in particular, I focus on a set of capabilities and content that we call accelerators, all with the aim of simplifying the development and delivery of building cloud-native applications in the enterprise. I'm joined today by my colleague, Chris Bailey, who's chief architect for this. He'll be on the Q&A helping out as I'm presenting and afterwards as well. So I'd like to start by giving a bit of context around the Cloud Pak for Applications, the motivation for the approach that we've taken with this offering, and ultimately what's in the box. But I'll focus primarily on, as I say, the development of cloud-native solutions, including some tech preview enhancements we've recently delivered in version 4.2. If the demo deities are with us, I will hopefully show you some of this in action. We should leave some time for Q&A at the end as well. So broadly looking at the application space today, we kind of see these three challenges fairly ubiquitously across enterprises. And in a way, they're very familiar, but perhaps they have some nuances in the new world of hybrid multi-cloud. So that's namely, how can you deliver faster? How can you contain operational costs, which are ever increasing? And partly what's causing that high cost is the complexity that we're seeing as enterprises are also adopting this transformational journey that they're on from legacy applications and methodologies towards the cloud native platform. And what does all this mean? Obviously, there are a lot of different viewpoints on this. I've called out one here. This is an analyst report from the IDC. You can kind of see on the left some of the stats that they're calling out that over the next few years, we are going to see an increase in cloud native development for applications. We're going to see a huge increase in the number of daily deployments, and that's kind of driven by more broad adoption of DevOps practices. And all of this is ultimately underpinned by this great shift we've seen towards deployments on containers. And on the right-hand side, they kind of talk about the need for a deployment and development platform, which helps you build these applications which can run across distributed infrastructures. That it talks about this concept of an application stack to provide those cloud-native capabilities that we think of like elastic scalability, the operational concerns. And key to all of this is a microservice development or like a microservice architecture for development, and key technologies emerging such as Docker containers and Kubernetes. And we're going to talk in this presentation about how through accelerators, hopefully we can drive towards this future state where teams are more efficient. So we kind of believe with the Cloud Pak for Applications that any successful application strategy requires you to be able to balance your investments. So to be able to deliver those new experiences for your customers more rapidly and not be disrupted by new companies emerging in your industry, but that you also have this existing investment and those business critical applications that you need to keep running. They need to stay on supported versions of software, and for some of them, you will also want to unlock more value in them. So how do you bring them into a containerized world? How do you provide APIs so that they can be leveraged by your new cloud native applications? And with Cloud Pak for Apps, basically what we want to try and do is to provide everything that you need for today and what you will need tomorrow. And it would be very rude for me to not mention OpenShift in an OpenShift Commons briefing. So across our portfolio, we've been going down a container-based direction for quite some time now, specifically a Kubernetes-based direction. We see containers as kind of the practical way of achieving multi-cloud portable workloads, and Kubernetes as that way to have a common management and orchestration for those workloads. Together, IBM and Red Hat have contributed to almost every part of the Kubernetes platform. And we do truly believe that building this in the open has been critical to both the breadth of the ecosystem that's built up and the rapid pace of innovation and adoption that we've seen around these technologies. But we also see that what's crucial to our customers in particular is that it's the integration of that innovation into a coherent, secure, and supported offering. And that's why IBM in particular has really doubled down on OpenShift as the foundation for our Cloud Pak strategy, where we deliver a common experience for all of our solutions now. This is kind of our bill of materials for what's in Cloud Pak for Apps at the moment. As you can see on the top left, we have the licenses for those traditional runtimes, the familiar WebSphere family of products and JBoss EAP. In the bottom left, we have a rich set of modernization tooling to help you unlock the value in those investments. So this can help you analyze binaries and start to move towards containerized deployments. And on the right-hand side, which is what we'll talk about today, is how to develop cloud-native, like new applications. So this includes the OpenShift platform, the complete set of IBM and Red Hat runtimes, developer tooling, and the set of capabilities that we've called Accelerators for Teams. Coupled alongside this, Cloud Pak for Apps has this concept of a ratio table within its license that basically allows you to repurpose your entitlement over time at a pace which suits your particular company's modernization journey. So when looking towards cloud native, we kind of see enterprises having to face two challenges at once. Namely, how do they deliver faster, but how do they retain enterprise governance? And solving these at the same time can be quite challenging. We started doing some research and some interviews with some of our clients, and this was a developer journey for an EU bank, and what they were basically telling us was that it was quite typical that it would take 90 days to develop and deploy a new solution. And as you can see from this, the emotional journey that this developer's on is not a particularly pleasant one. And a lot of time is getting spent bogged down just getting set up, getting infrastructure and onboarded, and actually getting configuration and integration right. We saw this particularly as they were starting to move those applications out of development into staging and production environments. And what we'd like to do with Accelerators is to transform this cycle into one where a developer truly feels productive for like the whole time that they're engaged on the project. And this is our notion that we want to take that 40 days into a matter of hours through the ability to kind of codify the decisions that were being taken and handoffs that were being made between teams. So what we try to do with Accelerators is to enable multidisciplinary teams. So that is anyone with a vested say in how a solution ultimately gets delivered, to collaborate and codify their decisions so that developers are empowered and safeguards are in place so that issues aren't encountered further down the line. And we provide content and capabilities across the full SDLC. So starting on the left, like how do folks actually design and ideate around a cloud-native solution to solve a business problem? We provide a set of content with the IBM Garage. So these are services organization who have best practice agile principles. They have a set of proven out reference architectures, and we've built exemplar applications using those and the Cloud Pak for applications. We provide a collaborative solution development tool, which helps development teams actually be productive much faster. And ultimately, this allows us to automate day zero, if you will, as well as capabilities to ensure that you've got true CI/CD and speed of delivery and day two operation, like observability and maintenance. So it's not just day zero, it's everything for the lifetime of this application. Now, the core set of capabilities that we have been working on across version 4 of Cloud Pak for Applications are application stacks, developer tooling to help create applications with those stacks, and tool chains to facilitate the building and deployment of those applications in a governed way. Starting with developer tooling, we kind of recognize that it's important to let developers use the tools and IDEs that they love. So we have always tried to take a flexible approach. Where we have had to introduce new concepts like the application stack, we're making sure we're supporting developers use them in an easy way. We've been working very closely with Red Hat on this to have a consistent, opinionated view on how folks should be developing cloud-native applications. So whilst we had initially started with a CLI, which we'd open source called Apsody, we've recently announced that we have started to move towards Odoo, and in future we'll provide the same capabilities through Odoo instead. And this is one of the examples of where we're starting to converge on technology choices. Looking now at application stacks themselves, so the best way to kind of think of these is a best practice technology stack for containerized applications. So this will include a particular runtime and framework. We support the full set of IBM Red Hat runtimes here, so you can see OpenLiberty, the new Quarkus runtime, Node.js, Spring Boot. They include common operational capabilities. So for example, health checks, so that an application can be automatically restarted. We include endpoints for monitoring and for open tracing. The stacks themselves are semantically versioned for auditability and control of updates. We provide a lot of labels on the actual deployed artifacts so that you can trace back to where this application has come from. And this allows an enterprise to kind of deploy and manage these applications at scale. They are, of course, completely customizable, so they are a starting point, but obviously we recognize that you may want to change a particular technology choice based on something that you're already using, or you would like to provide a stack which better suits a particular workload type, shall we say. And one way that you can do this is through this concept of stack inheritance. So stacks can build on previous levels of stacks, and you can gradually abstract concerns away from the application developer. So on the left, we kind of have like this base stack for Node.js, which is very similar to an S2I approach, where you package your application in a best practice Docker file. Within what we call the cloud native stacks, such as Node.js Express, this is where we include a pre-configured Express server, which has those endpoints I mentioned for metrics, monitoring, health, things like that. And you can even go a step further. We don't include this in Cloud Pak for applications, but we've prototyped it in open source, where you can basically provide a functions as a service like programming model by including the Connect middleware. So a developer just has to write a request handler effectively. And one of the great things about this is it also allows for much easier maintenance. So for example, if I wanted to bump the version of Node.js in that base stack from 12 to 14, any stacks which extend that would also be updated. So the Node.js Express stack and all those applications built from either would just have to be rebuilt to get that update. Finally, we'll take a quick look at the pipelines that we provide. So we provide a set of pre-configured tasks. It's all based on Tekton running on OpenShift pipelines that can easily be triggered through webhooks and GitHub to set up a CI/CD workflow. And one of the great things, or one of the reasons that we chose Tekton in particular, is that it's a Kubernetes native technology, which allows for a much more consistent approach in how you manage your overall technology stack for application development and deployment. We provide a set of capabilities for running tests, for linting, for signing images, and for verifying that the development stack that someone has chosen to use is one that is approved for the particular deployment environment that you're targeting. So I'd now like to talk to some of the tech preview additions that we've made. And this is where things get quite interesting. So as I mentioned, we look to provide content which spans across the full SDLC and that truly enable multidisciplinary teams to collaborate and build solutions. The most recent capabilities that we've added are to help architects and business owners in particular lay out a cloud-native application topology of multiple connected microservices and backing services that can solve a business problem, whilst continuing to ensure that developers are productive and that these solutions can be delivered quickly. And we're starting with kind of the fundamental building blocks for those solutions, so namely microservices which communicate over REST, and microservices which are event-driven, so reactive microservices, perhaps using a technology such as Apache Kafka. So I'd like to walk you through the workflow that we have with these. So we start off with what we provide through the garage as best practice reference architectures. We actually bring this into this workflow. We have the best practice application stacks for creating applications. We deploy through a series of operators, which I'll talk about in a bit. Clients can work either with the garage or entirely using the on-demand materials that they have through things like the Cloud Architecture Center. And a solution architect and business owner can start to collaborate in this tool we call Solution Builder. This allows them to load those reference architectures to learn from or start from scratch as a blank canvas and drag components onto it to design their intended solution. They can then generate that topology, and what this will do is set up all the Git repos for the microservices, as well as GitOps repos for configuration. I will talk a little bit about GitOps in a moment. We provide the build pipelines so that you can go from the microservice source code to the GitOps repository, which will have the built image ready for deployment. And we also provide the deployment pipelines and the operators so that you can actually run those applications on OpenShift. And these will automatically connect to each other. They will be viewable in the OpenShift topology viewer. They will basically paint as green before an application developer is even involved. When they do get involved, they simply have to check out the respective GitHub repo. They can start to commit their changes. Those will trigger build and deploy pipelines. And of course, operations aren't ignored from this. They have full control of how things get deployed through that configuration as code approach with GitOps. I did promise I would talk a little bit about GitOps. So this is a methodology which is starting to emerge. Weaveworks, I believe, coined the term and do have a very good blog if you'd like to find out a bit more about it. But effectively, it is configuration as code. And it allows you to record your intended state for a Kubernetes deployment within your source code repos or within source code control so that you have that audit trail. It's very easy to do rollback and to promote between different environments. So the approach we've taken is to have a GitOps repo per environment. Developer checks in code that automatically gets propagated to the dev environment. Pipelines will deploy those to a development environment on OpenShift. Once you're kind of happy with that, we provide a tool called Services Promote, which will collect all the information from the dev repo, propagate that into the production repo, and then trigger another set of pipelines to deploy. We also use this tool called Customize, which is now baked into kubectl itself, and that allows us to tailor the configuration through overlays. So things like the number of instances you would like, that can be altered between development and production environment without having to change the application itself. It's all underpinned by another concept we're introducing called service binding. So service binding is an open specification which both Red Hat and IBM and a number of vendors have been collaborating on, working to define and working to provide services which are coherent too, so that people know how to connect to them. And it basically enables the dynamic discovery and configuration of microservice to microservice and microservice to backend service. How does it work? So if we look at an example, so this is a very, very simple topology. I have microservice A, microservice B, which have a dependency on microservice C. If you're familiar with OpenShift and Kubernetes, this might be a typical location for those microservices. Storefront dev is the name of my namespace. It's exposing on microservice A, microservice B are exposing on port 3000 because they're Node.js and that's their default. Microservice C is Java, exposes on 9080. So if you were to connect to these, you would usually need to know that up front. And that means that you can actually code that into your application, but it means that you end up very tightly coupled. Or ideally, you would want to be able to do it dynamically. And the way that we can do this, so this is a truncated version of our deployment configuration for microservice C. And the addition that I've highlighted here is this statement, which basically says, I'm going to provide an open API, so a REST-based endpoint for other microservices to connect to. And the effect of that is that we use it to create what's called a secret. And this is a way of basically passing configuration around. And within that secret, we put the full address for the microservice, including its port, potentially any operational or optional context. So if you wanted to, say, respond to V2, because you're using V2 of the API, all of that can be put into the secret. Microservice C creates this, and it's basically a container of configuration on how to connect to it. So what microservice A now does, so this is, for example, a Node.js frontend that wants to connect to C. In its deployment YAML, it adds a consumes statement, which says, I'm looking for something called microservice C, which exposes a REST point, and basically says, give me that secret. So we take it, we inject it into microservice A. By default, we do this through setting up some environment variables so that the application can read from those variables and knows how to connect to microservice C. The same secret can be injected into microservice B. What's important is that they no longer need to know in advance the location for that microservice C. Instead, they're dynamically discovering it by stating that they consume microservice C. And this is useful for when you start to move where that microservice is located. So for example, if I move microservice C to a staging environment and it suggests now changes, I don't have to change anything in microservice A or B because that discovery and that connection is all handled through the secret. That's microservice to microservice discovery. With databases, it's a slightly different process, but effectively works in the same way. We use something called the service binding operator. And microservice C will create a service binding request. The first part of this, the backing service selector, basically asks to look up for a particular service and for a secret to be created if it doesn't already exist. And within that secret, just as before, it puts the full address for the database. But what it also adds is the credentials that are required on how to connect to that database. So the reason this is an advantage is because the alternative is you would have to either store this within the application source code or within the application configuration in the GitOps repository. And generally, it's accepted that storing credentials in this way is a bad idea. And I think we've seen a number of recent exploits of this, which have been very public. So that's the secret created for the backend service. The next step is to sort of say which microservice actually needs this. So within the application selector, we're saying that this is required by microservice C, and that will then get the secret and have that information injected in the same way as before. So with the combination of service binding and produces consume statements, we now have full dynamic discovery and configuration for both microservice to microservice and microservice to backend service. And this allows for true portability of applications through different environments. So I'd now like to stop sharing the presentation, and instead, if the demo gods are with me, we will share a live demo. Just give me one moment. I'm going to assume everyone can see my screen, so please shout if you can't. In the purposes of transparency, I'm going to set up an entirely new GitHub organization, just to show that I'm not cheating, and introduce you to Solution Builder. I'll make it a little bit bigger so that hopefully you can see it. So this is a tool that we use to design application topologies. As I mentioned, it includes reference architectures that we have collaborated with the IBM Garage on. This one, Coffee Shop, was actually from a collaboration with Red Hat in how to explore the difference between REST-based microservices and reactive. It uses Quarkus as well as OpenLiberty. We have Storefront, which is a simple REST e-commerce solution with WebBFF pattern for backend microservices, which connect to their own respective data stores. Well, as I say, you can start from scratch. We provide 3 components at the moment: REST microservices, reactive microservices, and a database. I can click and drag them into a topology just to make it easier to drag them together. So in this one, I'm going to have a reactive front end, a reactive backend, and a REST backend. And that reactive backend is going to connect to this Postgres database. So I can say within my reactive front end what topic I want to produce messages on. I can drag the connection between that front end to a backend. This will automatically receive the information for that topic. I can add bindings so that I can connect my reactive backend to a database. In the same way, I can add a binding to connect my reactive front end to a REST backend. You can give the components different names. You can choose on a base set of technology stacks. So if you didn't want to use Java OpenLiberty, you could use Spring Boot. You could use Node.js. You could use Quarkus. And within the blueprint itself, you can give the application a name, and you can provide some choices on how you want to do GitOps and how you want to configure Kafka should you be using that, which we automatically include if you start to include reactive components. So I'm going to start with Coffee Shop. I'm going to save this as my own version. I'm going to tell it to go to my newly created GitHub organization. I'm only going to create a dev GitOps environment for now, and everything else I am going to leave as default. Just going to save all that. And once I click generate, what that will do is scaffold out those GitHub repos and the GitOps repos that I was talking about earlier. So I just need to give it my token. I'm just going to quickly grab my key. So you can see it start to generate, and you can expand each of these nodes to see what it's doing. So basically what this is doing is creating the repos and then populating them with scaffolded out applications, which already have the appropriate configuration so that they are deployable to OpenShift and that they know how to connect to each other once they are. It shouldn't take too long for these ones, as I have run them fairly recently, and it caches most of them. There we go. So if I go back to my GitHub organization, do a refresh, you can see the 3 microservices that have been created and the GitOps repo. So I can now quickly show you what the development experience will be like as well. Just make sure that's empty. So I'm going to clone one of the microservices and open it up in VS Code. So within this, we have a very simple application. The base for a REST microservice basically just spits out a dummy hello world page, as well as the operational capabilities such as microprofile metrics, in this case, Open API, and what else does it have? All the deployment configuration, which we can see here. The important thing to notice is, as shown in the diagram, it has this provide statement, so that it is showing that I provide a REST API, and other microservices can connect to me. So that's a very quick demo of how quickly it is to get everything set up and running. I am going to go back to the presentation now, I believe. I just want to kind of like summarize what we've just seen. So the capabilities that we provide in Accelerators allow for multidisciplinary teams to design applications based on best practice reference architectures and compose solutions of connected microservices and backend services in Solution Builder. This can be used to automate the development, or automate day zero with all the required source code repos being set up, all the required configuration for easy deployment to Kubernetes and OpenShift, how to connect those microservices together. And GitOps is provided as a way to have a single source of truth for your deployments on OpenShift, which makes it a lot easier for operations to control and very easy to recreate should there be sort of like disaster recovery situation. The application stack capabilities that are provided as part of Cloud Pak for Apps mean that those scaffolded applications already have health checks for Kubernetes restarts, and they already have Prometheus metrics included, open tracing, performance dashboards, which can be visualized in Grafana, and the applications also show up logically within OpenShift topology viewer. The approach that we have taken with Cloud Pak for Applications is designed to help you meet the twin challenges of both deliver faster, retain governance, make sure that you're using pre-approved application stacks, but that all of this is based on open standards and open technology with, crucially, enterprise level support. Thank you very much for listening. That's been a lot of me talking, but hopefully not too long, and we have got some time for questions, so I'd like to stop sharing now.
Thank you, David. That was great. And I'm so happy that the demo worked. I mean, you talked a lot about, well, first of all, you said it's 4.2 tech preview for accelerators for teams. And just for people that are watching, that's 4.2 version of Cloud Pak for Applications, not OpenShift 4.2.
Correct. So Cloud Pak for Applications 4.2 includes OpenShift 4.4.
And when are you moving to other versions? So when does 4.3 come out, I guess, is better.
So Cloud Pak for Applications is on a quarterly release cycle, typically. So if you follow that train of thought, it would be third quarter when we see a new update.
So does that mean what you've shown tech preview will now be GA in third quarter? Because it's great.
Not necessarily. So the reason that we've put this out as tech preview is really to show the intent and the journey that we're on, but we want to make sure that we can really get feedback from our customers to inform the design decisions early on, because there's some things that we kind of know as inherently we will need to add, or new features that we will need to add, but we'd like to hear from our customers where they want to draw the line between what is a developer's concern, what is an operational concern, what configuration do they need to declare upfront when designing solutions, and how can we best help them. So we're already engaging with a number of our advisory board clients on this, but we wanted it in the hands of developers and architects as soon as possible, which is why it's take preview now.
Can you share with us some things that you're hearing from your clients on Azure?
So one thing that we saw very quickly is how we had designed the use of Kafka. So we currently have the point-to-point connections between reactive microservices. We found that there were some very common patterns where a microservice would produce and consume on the same topic. We didn't have a way to represent this with the view that we had set up. So we're currently working on a way which mitigates that, and the topic can be a sort of shared asset that's viewable in the viewer. We knew some things around securing communication with Kafka, which we currently aren't able to do, but a near update will be able to do some things along that line. We are hearing that a lot of folks have their own application stacks that they would like to bring in, so we're looking at how we can make this tool potentially more flexible. There's a number of very early requirements that we've had that are really exciting for us, because it shows us that appetite in what we're doing.
Sorry, I muted myself so I could listen to you. As you see you're showing us the journey, which is great. How do you see the journey going? How do you see cloud native development and what you're working on and GitOps? Where do you see the future going?
I'd actually like to ask that question of Chris, if he can share his views there.
Hang on just a second. I'm getting, which Chris? Sorry. Go ahead, Chris Bailey.
You have too many Chris's, sorry.
Go ahead, Chris.
Yeah, sure. So there were a couple of foundational pieces that you really need to start being able to build complex solutions and manage them at scale. So that was bringing in things like GitOps, so that you have a multi-component management system. It was bringing in service binding, which makes it possible for us to migrate applications between environments. That's kind of a foundational basis. So service binding is something that we now need to drive out through the community to get all of the providers of operators making that possible. Now, one of the things you'll then see in Solution Builder is that we'll start to dynamically read from the installed set of operators that implement service binding as a set of services and capabilities that you'll be able to use in Solution Builder. So the capabilities you'll be able to use will start to match what you've got available in your OpenShift install. But going beyond that, we'll start to look at some of the non-functional concerns. And by that, I mean things like security. So as David said, in Solution Builder today, we work with Streamzy as the implementation of Kafka, but it lays down an unsecure Kafka. And that's because we don't yet know what the security requirements would be for the application. So one of the things you'll see us start to do in the future is allow you to configure security policies. So should all of the traffic on a Kafka topic or between two REST-based microservices be encrypted and do certificate exchange? So we kind of got this foundational set of capabilities, but in the future, it's going to become more about the richer set of components you can use, the more complex applications, using greater sets of services, and then being able to start securing those, starting to potentially add requirements that you want to have in terms of performance and understanding what your performance criteria is, and building custom dashboards. So all of the components we lay down today are already, health check and metrics enabled, but you still have to build your own dashboard. The fact that we know the components you've got in Solution Builder, we know the services that you're using, like Kafka, we can actually automatically build custom dashboards that represent all of your microservices, represent the topics that are being used in Kafka, giving you an application level dashboard. And if you tell us things like performance requirements, then we can start to overlay, alert manager to alert you when SLAs are being missed, or for uptime or performance criteria at the front end.
And then I'm going to assume other day 2 operations, and then also, you mentioned high availability earlier, so more of those enterprise grade features.
Yeah, absolutely. The aim is to try and let that solution architect define not just the topology, but the requirements on the solution, and help them make that true.
Yeah, I think that's something that we've seen start to evolve a lot over the years in terms of like the X as code approach. So we talk about GitOps as configuration of code, but we're already seeing solutions around like compliance as code, and ultimately being able to store that decision in a way that can be policy enables a much faster delivery cycle, certainly. And it kind of couples with that idea of shift left, where if you can already put these concerns up front in the development lifecycle, you're much faster, and you don't have the more costly discovery and remediation when it comes later down the line.
Hey, Chris Short, I know you wanted to jump in too. You're welcome to.
No, I'm good now. Thank you, Chris Bailey, for chiming in. I appreciate that. Thank you.
No, that's that's great to hear the direction that you are going, especially all the enterprise grade and security. I know we would love to focus more on security as well. And I've heard you talk a lot about collaboration with Red Hat, such as service binding and other teams. And also the Tekton, you mentioned OpenShift pipelines now. So what are your thoughts on serverless or service mesh and other technologies that are coming out?
Yeah, certainly since the acquisition of Red Hat, what we've seen is Red Hat obviously stay an entirely independent organization, and that has been really critical to the growth of the OpenShift platform. But what it has allowed for is for IBM really to, as I say, like double down on the capabilities that are provided there, and to reduce the overlap that we've seen, or the competition that we've seen where necessary. So, for example, things like Knative as a way of doing serverless deployments of containerized applications. We started by shipping our own version of Knative, and now we work very closely with Red Hat on Red Hat Serverless. So we leverage that capability instead. In the same way we used to, well, I believe we used to use our own Istio, and now we use Red Hat Service Mesh instead, and starting to integrate with things like Kiali. So yes, there's definite collaboration and consolidation, I guess, because for us that allows us to build value on top of that, rather than be producing something that is fundamentally the same. So yeah, I think that's the trend that's going to continue to grow. And we're already looking at the new runtimes such as Quarkus, which is obviously a great choice for serverless Java. Chris, any additional thoughts?
Well, yeah, just to say that one of the things that we did in the runtime component operator, which is how we deploy and manage these services, is we made the use of Knative and OpenShift Serverless a deployment decision. So all of those microservices are already ready to be used using OpenShift Serverless. And all you have to do is in the app deploy.yaml, so your Kubernetes configuration for deployment, you can set a single flag to true, and that will deploy it as an OpenShift Serverless service rather than as a regular Kubernetes pod. So we built that in from day one, because serverless is something that's going to be becoming increasingly more important over time. So everything that we kind of lay out and we built, we kind of said that If you can't treat serverless as a scaling policy, right, what you're saying is you want to scale on demand from 0 up to however many requests you've got and then back to 0 afterwards. So it's a scaling policy. You could also have a scaling policy that said, I want to have 6 replicas. So that's the way we represented it in the runtime component operators configuration. You choose whether or not you want to have a scaling policy that is serverless, or whether you want to have a static number of replicas, or replicas plus pod auto scaling.
So how has it been working with open source? I know you have before in the past, but now diving further into it.
So I would certainly say for large parts of IBM, it's no different because we've been doing it for 10 or 15 years. I don't think there's a single project that I've worked in IBM that is not now open source. The first project I worked on that was IBM's implementation of Java, but that became open source through OpenJ9 and in the Eclipse ecosystem. So I think pretty much every line of code I've ever worked on in IBM is an open source. So for large swathes of IBM, it's been no different. And in fact, the fact that we've been collaborating with Red Hat on things like service binding, on GitOps, and so on, the fact that there was an acquisition, actually, it's not changed the approach, because all of this collaboration has been done through open source communities. And for a lot of the things, so Tecton, for example, now OpenShift pipelines, same with things like Istio, IBM and Red Hat were already collaborating through those open source communities. So in a lot of ways, things haven't really changed. We're still collaborating, but than we did before.
So it was kind of a leading question because I've seen a lot of the collaboration, especially runtimes and other teams and upstream projects, and it's always amazing seeing everybody work together, in the open fashion and seeing it better both, Cloud Paks for applications as well as the platform, the OpenShift container platform. So
absolutely.
Yeah. And I had other questions. Hey, Chris, do you have any other questions in the stream? Chris Short.
No, do not. Sorry.
That sounds good. Okay. Those were most of my questions too. Is there anything else that you would like our audience to understand about Cloud Pak applications, or your direction, or even any technical information, because we have a lot of technical people that watch this?
I think I've certainly spoken enough that my voice is going. I will let Chris add anything that I've missed.
I think that the only thing to kind of end with is, as David has said, what's out there in terms of, solution accelerators, solution builder, and so on. It's there as a tech preview. Our intent is to continue to build on it. And it's like any open source community or any tech preview product. The more feedback that we get from users, the more we can do to build something that actually does what users want it to do. So I encourage you to kind of reach out to myself, David, through whatever form works best, whether that's email, Twitter, LinkedIn, through any of the open source communities that we work in, and give us some feedback.
I'll put my our contact details, both email and Twitter, on the screen now. So if anyone does want to get in touch, please do.
Thank you. And some final thoughts too. You mentioned the service binding collaboration. The hour right before this one is the developer open office hours, and next week at the hour right before this one is going to be service binding. So open office hours on service binding. So anybody that wants to join that also. And commons.openshift.org you want to join the OpenShift Commons community, and this will be posted on the OpenShift Commons YouTube channel, as well as all the streaming services. So thank you again. Very much appreciate you joining us today and sharing all your insight.
No problem. Thank you very much for having us and giving us the opportunity.
And